This is an introductional video for the WES tool. The purpose is to demonstrate how the WES tool can be used for assessing ecosystem services for the SFP2 project area for here at Winrock. For an overview of how the WES tool works, please go to the link in the email that I sent that says watch video introduction to the WES tool. This is a more advanced version of that, the WES tool for SFP2. In that email, you also have a link to the WES tool, and attached to the email are a number of zip files, which are shape files which can be uploaded into the WES tool, which we'll demonstrate. Also in the email is an Excel document where we're going to cut and paste our results. So if you open up the WES tool, and we're going to jump straight to the analysis tab, we're not going to bother with all these introductory tabs, which you can review in the introduction video if you want to. And we're going to go over to this tool over here in the left-hand corner called All Analysis with Shapefile. Okay, we're going to open up that tool, and it's going to prompt us to add a shapefile. Those zip files from the email should have been downloaded somewhere that you can navigate to. Here I have it on my desktop, and I'm going to go to the Prelong boundary for this one. All these other boundaries are SFP2 boundaries, and I'm going to open it. And now it's going to load the shapefile into my map, and you'll see the Prelong boundary pop up in the map. Now, I'm going to let's take a look at a number of the tools that we can use to do analysis for that Prelong boundary. There's 8 tools in here that we can do analysis, that we can use to do analysis. And for reasons that I'll explain, I'm going to jump straight to this deforestation and greenhouse gas by land use analysis, and I'm going to hit the execute tab. And now the job is going to execute the analysis just for this Prelong boundary, so any boundary you put in there. And you'll notice it goes from the input tab over here to an output tab. Okay, so we'll navigate between those. And in the output, you get this nice table that you can assess on your own time or figure, and then you get a table below that that gives you all the data for greenhouse gas emissions for that area. I can now export that data to a CSV file, okay? And so it's going to download that CSV file, right? And if I take a look at that CSV file, now I have all the data in here, and I have the labels up there. Now what am I going to do for the analysis? I'm going to go to this results template Excel document that I sent, and I'm going to navigate to one of the tabs down here at the bottom that corresponds with the tool that I just ran. So it's Results Land Carbon Land Use. Okay, the same name of the tool is at the top of each of these tabs: deforestation and greenhouse gas emissions by land use type. Right? If I go back, I can see here that I've run that tool. Right? We just ran the deforestation and greenhouse gas by land use tool. Okay. And now if I take those results and I control copy those results into my template document, right here it prompts you to put them in there. So I'm going to cut and paste right there. It's going to now produce these figures for land use and for total emissions. And the other thing it's going to produce is the total area, the total forest area in 2013, total deforestation, annual average deforestation, percent forest area deforested between 2001 and 2013. It gives you all this data now that you can use for the SFP2 proposal. So let's go back now, moving along. We'll go to annual deforestation and greenhouse gas emissions. So this one's annual, right? So now we're going to execute that tool, and we still have the same shape file that it's executing just for the Prelong boundary here. But now it's going to give us results on an annual basis from 2001 to 2013. Again, we get this nice chart, but we can download those results and export it to CSV. Again, if I open up those results here, and I copy and paste those results into the template, into the right place in the template, and so I navigate to the tab, Results Land Carbon Year. Again, at the top of the tab, it says annual deforestation and greenhouse gas emissions, and that's the same as the tool in the west. It's the same name as the tool. And again, I'm going to cut and paste those results right into there. And then all those results then are populated into these figures. You can see now deforestation area, emissions from deforestation. You can see the comparison, the relationship between deforestation and CO2 emissions. And down here you can see some projections into the future using either a linear or a polynomial projection, something that we might use for a baseline, for example. If I go back to the WES tool and I go from the output back to the input tab here, I'm going to now take a look at annual sediment, nitrate, and aquifer recharge tool. Okay, so again, I'm just going to select that tool and I'm going to hit execute. And now it's going to run those results for sediment loss, right? So changes in sediment loss due to land use changes, changes in nitrate loss into the rivers due to land use changes, and changes in aquifer recharge due to land use changes. Again, you get this fancy chart, but the chart doesn't give us the whole story because there's more data in the table. So let's export that data now to CSV as we've done with the other ones. And I'm going to open that table now in CSV in Excel. And I'm going to copy and paste that into, again, my template under the right place where it says results soil water by year, right? Not by land use. This is by year because it's annual. And again, it prompts me to paste right there into the top of that white box area. And I'm going to paste my results there. And then it populates everything here. And if you look down now, we're going to take a look at the effects of deforestation on annual aquifer recharge. As deforestation goes up, there's less and less water entering the aquifers due to those land use changes. As deforestation goes up, the orange line, annual sediment rates also increase as forests are converted into croplands or plantations. And similarly, the effects of deforestation on annual nitrate loss. Okay, so now we can see those results for each of these three different categories: nitrate, sediment, and aquifer recharge. And within this template, it gives you some handy little explanations of what all of this means. Again, going back to the WES tool, I can go from the output tab back to the input tab, and I can run a number of different tools here. Okay, so this one's the impact of future development on forests. And if I execute this tool, it's going to tell me for the forest areas remaining in prairie long, how much carbon stocks remain in there and how much would be lost if 100% of it was converted to either cropland, plantation, or urban development. It's going to tell me the same results if the forest was all converted, what would happen to nitrate or sediment or aquifer recharge, right? So again, I can export that data to CSV. I can view the chart here. And if I open that figure right there and copy and paste into my Excel template, again, results from future development. So here's impacts of land use change, same title as the tool in the West. And if I paste here again, I get these results here. And again, we get an explanation of what these results mean. Basically, increases in sediment load resulting from forest conversion to either cropland, plantation, or urban, right? So there would be increasing amounts of sediment load each of these would have different amounts of sediment loss. Each of these would have different amounts of nutrients, right, entering the freshwater system. Each of them would have different amounts of the water refilling the aquifers, right? We're assuming that 100% of all the forests in prairie long now are deforested, and this is the greenhouse gas emissions. These are just some of the examples of how you could use this WES tool. You have in the email that I sent you a number of different shapefiles that are important boundaries for the SFB2 project. This is just an introduction. I hope it's helpful. Thanks so much.